Your electricity meter is spinning right now, not because you are running the dishwasher or the air conditioner. Instead, 40 devices in your house that appear to be off are silently drawing power through circuits engineered to never fully disconnect. That can cost $300 a year. The fix costs $10. It requires no electrician, no permit, and no technical skill. Just one trip to a hardware store and 15 minutes of this video. By the end, you will know exactly what to buy and exactly where to plug it in. Hi, I am Oliver, and welcome to Off-Grid Ohms. Subscribe and hit the bell for more uncovering electrical secrets. The electricity bleeding from your walls right now has a name. Researchers call it phantom load. Engineers call it vampire draw. At Lawrence Berkeley National Laboratory in California, a researcher named Alan Meyer has been measuring it for over 25 years. His team connected monitoring equipment to thousands of devices across hundreds of American homes. What they found was not subtle. The average household contains more than 40 products pulling standby power at all times, whether anyone is home or not. Meyer called it leaking electricity. The term is precise because the current flows exactly like a dripping faucet, too slow to notice and too constant to ignore once you measure it. In 2015, the Natural Resources Defense Council published the most comprehensive phantom load study ever conducted on American homes. Researchers in Northern California installed plug-level monitoring equipment in 70 households and collected more than 70,000 data points. The measured results stopped people in their tracks. The average home's always-on consumption burned through roughly 1,200 to 1,400 kilowatt hours per year. That is 23% of the total electric bill going to devices no one is using. Multiply a conservative average of $150 per household across 130 million American homes, and the number reaches $19 billion per year. Published in peer-reviewed research, confirmed across multiple studies. Walk through your own house and the numbers stack fast. That cable box under your television draws 25 to 45 watts even when the screen is black. That is $30 to $50 a year for a box doing nothing. The game console running in instant on mode pulls 10 to 15 watts around the clock, $15 to $20 a year to save 3 seconds of boot time. The microwave on your kitchen counter draws 3 to 4 watts continuously just to display a clock you probably check on your phone anyway. The inkjet printer in your home office, the audio receiver behind your speakers, the garage door opener, each one bleeding power through circuits that were designed to never fully disconnect. None of this is the result of careless behavior or bad wiring. These circuits were deliberately engineered to stay partially alive at all times. Your grandfather's house did not have this problem, not because he was more careful, because his appliances were built differently. Before 1970, every appliance sold in America came with a mechanical toggle switch. It was a single-pole, single-throw design with metal contacts inside the switch housing. When your grandfather turned off his Philco radio in 1955, those contacts physically separated. The circuit broke. Zero current flowed through the wire. Off meant off, not standby, not sleep mode. Off! A typical American home in that era had 8 to 12 plugged-in devices. The combined standby draw across the entire house was 0 watts, $0 wasted. In the early 1970s, remote control televisions reached mainstream American living rooms. Magnavox and Zenith were among the first to ship them widely, from plants like Magnavox's facility in Fort Wayne, Indiana. Early remotes used ultrasonic signals rather than infrared, but the engineering consequence was identical. For a television to respond to a signal from a remote, it needs a receiving circuit that is powered on and listening at all times. That receiver draws current continuously. It cannot be switched off or it will stop listening. Within a decade, Zenith, RCA, Sony, and Panasonic had all followed. By the mid-1980s, soft-touch momentary buttons had replaced mechanical toggles across the consumer electronics industry. The button no longer broke the circuit. It sent a logic signal to a microcontroller that transitioned the device into a lower power state. But lower power is not no power. The age of true off was over. It ended not because the old design failed, but because the new design was cheaper to manufacture in factories across Shenzhen and easier to sell in showrooms across America. Through the 1990s and the early 2000s, the problem compounded. External power supplies spread across every room of the house. Phone chargers, laptop adapters, wireless speaker systems, baby monitors. Each one contains a transformer that draws current whenever it is plugged in, regardless of whether any device is attached. By 2000, the average home had 25 to 30 always-on devices. By 2015, more than 40. By 2024, closer to 65. Then came the smart home era, with Wi-Fi chips demanding constant network handshakes and instant on features marketed as premium convenience, 10 to 15 watts per device, around the clock. You gain 3 seconds of boot time. You lose $15 to $20 per year per device. That trade-off was never printed on the packaging. Every one of these changes was presented as progress, convenience, modernity, better living through technology, but other countries looked at the same data and reached a very different conclusion. In 1999, the International Energy Agency in Paris proposed something called the 1-watt plan. No device should draw more than 1 watt in standby by 2010. The European Union adopted it, Australia adopted it, South Korea adopted it. The United States acknowledged the plan but never passed mandatory standby limits. In 2008, the European Commission passed Regulation 1275. It mandated a maximum standby draw of 1 watt by 2010, tightened to half a watt by 2013. It covered televisions and computers and printers and game consoles and audio equipment across all 27 member states. Factories across Asia retooled their circuit boards. Engineers in Munich and Eindhoven redesigned power management systems. The result was 35 terawatt-hours saved per year across the European Union, roughly equivalent to the entire annual electricity consumption of Denmark. An entire country's worth of power saved by requiring a half-a-watt limit on devices that are turned off. In South Korea, the government launched the e-standby program in 2005. Products that exceeded the 1-watt standby limit were required to carry a warning label at point of sale. Shoppers in electronics stores in Seoul could see at a glance which devices bled power and which did not. Within 5 years, national standby consumption dropped by nearly half, according to government reports. Now here is the fact that should make your jaw tighten. The same manufacturers who redesigned their products to meet half-a-watt standby standards in Berlin and Seoul and Sydney continued shipping devices to American homes drawing 15 to 35 watts in standby. Same companies, same product lines, same factories in Shenzhen and Guangzhou. Different power management configurations applied based on which market the product was destined for. Samsung, Sony, LG, Panasonic. They proved sub-half-watt standby was achievable at negligible cost per unit. Then they chose not to apply it to the American market because nobody in Washington made them. So the technology exists, the regulation exists, the proof that it works at national scale exists on 3 continents with published data spanning more than 15 years. The question is why your house still bleeds up to $300 a year when the rest of the developed world fixed this over a decade ago. Follow the money, and the picture becomes very clear, very fast. Most American utilities operate under rate structures where revenue scales directly with consumption. Your phantom load of up to $300 a year is guaranteed income for your utility company. It is revenue that requires no additional power plants, no new transmission lines, no maintenance crews, just a meter that keeps spinning while you sleep. Multiply that across 130 million households, and phantom load alone represents a $19 billion annual revenue stream that no executive in a utility boardroom has any incentive to eliminate. In 2016, the United States Department of Energy proposed mandatory efficiency standards for cable and satellite set-top boxes. These are among the worst offenders in the American home. They draw 25 to 45 watts continuously even when the screen shows nothing, costing up to $50 a year per box. The proposal went through public comment, and then lobbyists from the Consumer Technology Association and the National Cable and Telecommunications Association walked into government offices in Washington and flooded the proceedings with formal opposition. In 2017, the Department of Energy quietly withdrew the rule. One device, one common-sense regulation killed in a hallway before it ever reached a single American outlet. No major utility has ever run a public awareness campaign about phantom load, and no appliance retailer labels standby draw at point of sale. This is $19 billion in documented annual waste, confirmed by federal laboratories and published in peer-reviewed journals. It is mentioned by no one with a financial stake in the outcome. Here is what none of them can take from you. A power strip with a toggle switch costs $10 at any hardware store in America. And the physics of a broken circuit has not changed since your grandfather flipped off his Philco. This is not complicated. A switch that physically breaks an electrical circuit draws 0 watts. This is Ohm's law applied at the outlet. Your grandfather understood this without ever reading the formula because every appliance he owned came with a switch that actually disconnected. A basic surge protecting power strip with a red toggle does the exact same thing his mechanical switch did. It opens the contacts, current stops, the meter stops spinning, $5 to $10 at any hardware store from coast to coast. The smarter version costs more, and it does the thinking for you. A smart power strip uses a master and controlled outlet configuration. You plug your television into the master outlet. Everything else on that entertainment center goes into the controlled outlets, the soundbar, the streaming box, the game console. When you turn off the television and its current draw drops below a threshold, the strip detects the change and cuts power to every controlled outlet automatically. Everything goes to true zero. No standby, no meter spinning. When you turn the television back on, the strip senses the current rise and restores power to the peripherals instantly. $15 to $35 payback on a typical entertainment center in 4 to 8 weeks. Walk through your house room by room and map the savings yourself. The entertainment center with its stack of black boxes draws 50 to 90 watts, costing $60 to $100 a year. One smart strip eliminates it. The home office with the monitor and the desktop and the printer and the desk lamp pulls 15 to 30 watts, costing $20 to $40 a year. One strip recovers it. The kitchen counter where the microwave and the coffee maker sit plugged in bleeds 10 to 15 watts. The garage with battery chargers and a compressor and shop tools adds another 20 to 40 watts. The bedroom with its second television and alarm clock and tangled phone chargers contributes 10 to 20 more. Your grandfather never needed a guide for this. His appliances came with switches that meant something. Somewhere between 1972 and today, off stopped meaning off. A $10 power strip puts it back. The physics of an open circuit is older than every utility company in America, older than every electronics manufacturer on Earth, older than every lobbying firm that keeps your meter turning in the dark. It is as fundamental as gravity and just as indifferent to who profits from you not knowing about it. The European Union proved that mandatory standby limits work. Consumption dropped across an entire continent. Manufacturers retooled their circuits within the compliance window. Nobody lost access to a television or a computer or a microwave. The lights stayed on. The only thing that changed was that meters stopped spinning for nothing. The United States chose a different path. Not because the technology failed, not because the engineering was uncertain, because $19 billion in annual waste is $19 billion in annual revenue for someone sitting in a boardroom who decided their balance sheet mattered more than your electric bill. A toggle switch on a $10 power strip does not require a regulation. It does not require a permit. It does not require anyone's permission. Your grandfather's Philco had a switch that meant off. For $10, yours can too. The electricity has been bleeding quietly for decades. The fix has been sitting on a hardware store shelf the entire time. If this changed how you think about electricity, please subscribe to Off-Grid Ohms with Oliver. Please watch the next video appearing on your screen right now.